In this video, we will look at how to find the shortest distance between a point and a line. But before we get to that, I want us to think about a triangle. And the height in a triangle is always the shortest distance from a vertex to the opposite side. So if we just look over here at this triangle, let's say CEF, the height or the altitude from C to D, that's the shortest distance. If I were to draw a random line that isn't the height, so let's say this line here or this line here, you can clearly see that those lines are larger just by thinking about a right triangle. In this right triangle, because the right angle is right here, this would be the hypotenuse, and the hypotenuse is the largest side. So this is definitely not shorter than the height. And you can do that to any line in your triangle, and every line other than the altitude will be longer. So the main thing that we have to think about here is that in order for us to find the shortest distance, we need the altitude. And once we have the altitude, so let's say this right here, and we have our other line segment, we just need to figure out the distance from this point C to this point D. And point D is the point of intersection between the altitude and the line that is given. And once you have 2 points and you want to find the distance between them, we can use our distance formula. So this process can be quite tedious, but if you think about it logically, the steps are there for you. And you already have the knowledge of finding an altitude, finding a point of intersection using substitution or elimination, and you know your distance formula. So here we are just applying those skills. So let's start with our first example. Determine the shortest distance from the point 3, 5 to the line 1/2 x minus 4. So let's go ahead and plot the point and draw the line just for a visual. Now this isn't necessary, but for the first time, it's a good idea. So 3, 5 is here, that's my point. And then for the line, I'm just going to use my knowledge of y equals mx plus b. -4 is my y-intercept. And my slope is 1/2, which means I'm rising 1 and running 2. So I'm just going to do that across so that I can accurately draw my line. And you do want to do this with a ruler if possible, and then I will draw arrows at the ends of my line. All right, so now we have our line, we have our point, and if I want the shortest distance, we have to think about the altitude. So I'm gonna roughly draw in my altitude. And it might look something like this, okay? There's my altitude from my point to my line. Now, just drawing that, I already know I need to figure out what this point is accurately, and then I already have the point 3, 5. I just need to figure out that accurate point, and then I can do my distance formula. Now, I know that my altitude has to be perpendicular to this line that's given to me, and I know the slope of this line. The slope of this line is 1/2 because that was given in our equation. So my altitude slope is going to be perpendicular to that, so we have to take a negative reciprocal. So 1/2 is positive, so our negative reciprocal will be negative, and the reciprocal of 1/2 is 2/1, or just 2. So we already know our slope. So step 1 is to find the altitude. And we already mentioned that our slope is going to be -2. Now the only other point that I know that belongs on the altitude is the point that's given to me, this 3, 5. So now I have the slope of my altitude and I have a point, so I'm just going to do that y equals mx plus b process. So I'm going to plug in my slope, so -2x plus b. Now we can plug in our point. 5 is y, x is 3, and now we clean up. -2 times 3 is -6. Let's bring the -6 over to the other side. It becomes positive. And then 5 plus 6 is 11. So there's my altitude. Y equals -2x plus 11. Now I have my altitude. I already have the equation of my line, it was given to me. Sometimes it might not be given to you, like in our next example, but right now it was given to us. So now I have two lines. I just need to figure out this point of intersection. So our step 2 is to find the point of intersection. And after that, we'll have 2 points and we can use our distance formula. Now, for the point of intersection, you can do substitution or elimination. Like I've said in another video, when both of my lines are in y equals mx plus b, I just like to do substitution because I know that y is equal to negative 2x. There's a y in my second equation, so I just do a little substitution there. So I'm going to write negative 2x plus 11 for y, and that's equal to 1/2 x minus 4. Now, there are two different things you can do right now. If you'd like, you can just deal with the fraction, bring it over, get a common denominator, all of that. Or if you'd like to get rid of all of your fractions, you can get a common denominator for everything to cancel them out. The choice is yours here. Now, I'll show both ways. So one way is to just start moving things over. So negative 2x minus 1/2 x equals negative 4 minus 11. Now I have no problem on the right side. Negative 4 minus 11 is negative 15. Now on the left side, I need a common denominator in order for me to subtract these x's. So I'm going to multiply negative 2 over 1 by 2. So negative 4 over 2 minus 1 over 2x. Now I can do my subtraction so that I have negative 5 over 2x's equals negative 15. Now you can divide both sides by negative 5 over 2, which really means you're multiplying both sides by 2 over 5. You can show it however way you would like, or if you'd like, you can get your common denominator right now, or you can do some cross multiplication. The choice, again, is yours. It depends on what you like to do with fractions. So I personally, I'm just going to cross multiply here. So do a little cross multiplication there, and I have negative 5x times 1 is negative 5x. 2 times negative 15 is negative 30, and then we can divide both sides by negative 5. So that x equals 6. And then from there, we can just replace x with 6 in either equation. I'm just going to do it into that first one that doesn't have a fraction. So negative 2 times 6 plus 11. That gives us a negative 12 plus 11, which is negative 1. So there's our point of intersection, 6, negative 1. And now let me quickly just show you, if you want to get rid of the fraction right away, this is something that you can do instead. So I'm going to put all of these over 1, but I want them all to have a common denominator. So everything's going to get multiplied by 2 to get that common denominator. So negative 2x over 1 will become negative 4x over 2. 11 over 1 will become 22 over 2. The 1/2 x, I'm just going to write it as 1x over 2. And then negative 4 over 1 will become 8 over 2. Everything got multiplied by 2, top and bottom. And now you're technically multiplying everything by 2 to cancel out the denominator. So now you can just solve the equation negative 4x plus 22 equals x minus 8, and you'll get to the same place that we did before. So the choice is yours if you want to deal with the fraction throughout or if you want to get rid of it. Now that we have our point of intersection, step 3 is to find that shortest distance. So I'm just going to go up to my diagram here. There's the point 6, negative 1 that we just figured out, and we want to find the distance from 3, 5 to 6, negative 1, and then we can just use our distance formula. So I'm going to write those points down so I don't mess them up. And now, if you'd like to label them, you're more than welcome to. Otherwise, jump straight into your distance formula. So x2 minus x1 all squared plus y2 minus y1 all squared. And again, if you wanted to put the y's first, that's totally fine. And now we can clean up. 6 minus 3 is 3. And then I'm going to square that. Negative 1 minus 5 is negative 6. And I'm going to square that as well. And then just a reminder, when you do negative 6 squared, a negative number squared will still become positive because negative times negative is positive. So the exact answer for my distance is the square root of 45. But then we can plug that into our calculator and get a rounded answer if we'd like to. And that rounded answer is going to be approximately 6.7 units. And there it is. We found an altitude, we found a point of intersection, and then we were able to use our distance formula. And again, if you just sketch the scenario you're given, then it should guide your steps. You drew in an altitude, so we found the equation. We saw we needed a point of intersection, so we did substitution. And then you can do your distance formula at the end. All right, let's try another example, but this one is slightly, not necessarily more difficult, but it has a few extra steps in it. So in this example, plot the points A, B, and C, and then we want to determine the shortest distance from point C to line AB. So notice I didn't actually give you the equation of the line for AB, which means that's an extra step we're going to take. But after that, it's the exact same as the original scenario. So let's go ahead and start off by plotting our points. We have the point negative 1, 4 for A. B is at 3, negative 2. And that's the line segment we need. So I'm going to go ahead and connect those dots. And then point C is at negative 2, 1. Okay, so I need the shortest distance from C to the line segment I just drew. The fact that I just drew line segment AB tells me my first step is to find the equation of AB. Because I know at some point I'm going to need to do a point of intersection, and in order to do the point of intersection and do substitution or elimination, I need two lines, and right now I don't have any. So let's go ahead and start off by finding the equation of line AB. And this is just grade 9. You're given 2 points. You're given the coordinates of A and B. Let's find the equation of that line, which means step 1, find your slope. So I'm going to do y2 minus y1. Which means negative 2 minus 4 over x2 minus x1, 3 minus negative 1. And if I clean that up, I end up with negative 6 over 4, which reduces to negative 3 over 2. Okay, so I have the slope. Now I can plug either point in for me to find the actual equation of this line. So I'm going to put my slope in, negative 3 over 2x plus b. And I'm just going to pick that first point. The y coordinate is 4. The x coordinate is negative 1, which I'll just write as negative 1 over 1. Now I'll do my multiplication. Remember, with fractions, multiply your numerators, multiply your denominators. So negative times negative is positive. So positive 3 over 2. And now I know I'm going to bring this over, which means that 4 over 1 will have to turn into something over 2. So I'm going to multiply top and bottom by 2. To get 8 over 2 minus 3 over 2 for B. So that's 5 over 2. So the equation of AB is y equals negative 3 over 2x plus 5 over 2. So that's good. I have that, and I know I need that for the point of intersection later on. Now, let's go back to our diagram. I have the equation of line AB. And now we're back to the previous scenario. I need the shortest distance, which means I need my altitude right here. So that once I have the altitude, I can find that point of intersection and do my distance. So step 2, let's find the altitude. Now we already found the slope of line AB up there. So my perpendicular slope, I'm going to take a negative reciprocal. So I'm going from a negative slope, so my slope will be positive. And then the reciprocal of 3 over 2 is going to be 2 over 3. And the only point that I know is on my altitude is point C, which is negative 2, 1. So I'm going to do my y equals mx plus b. So y equals 2 over 3x plus b. I put my 1 in for y. I'm going to put negative 2 in for x, but I'm going to write it as negative 2 over 1. And then again, multiply your numerators to get negative 4, multiply your denominators. And then again, we have fractions. So I'm going to put the 1 over 1 to get a common denominator here. And my common denominator is 3, so I'm going to multiply top and bottom of 1 over 1 by 3. So 3 over 3 plus 4 over 3 equals b. And remember to switch the sign when you move something over to the other side, so that we get 7 over 3 for b. So the equation of my altitude is y equals 2 over 3x plus 7 over 3. So quite a few fractions here, but that's okay. So now I have the equation of this blue line, this red line, and the whole purpose was to find that point of intersection so I can find the distance. So step 3, point of intersection. Now I have highlighted my two equations here. I've boxed them, and I am going to do substitution. So this is what y is equal to, and there's a y right here. So I'm going to sub one equation into the other. So negative 3 over 2x plus 5 over 2 equals 2 over 3x plus 7 over 3. Now, like I said in the previous example, you can deal with this however you'd like. Maybe you want to do some swapping now. Maybe you want to get rid of the fractions right away. I'm just going to get a common denominator to wipe my denominators out of it so that I don't have to deal with fractions anymore. And my common denominator here is going to be 6. So I'm going to multiply my first two fractions by 3 and my second two fractions by 2 to get that denominator to be a 6. So then we have negative 9 over 6x that I'm going to put up in the numerator plus 15 over 6 equals 4x over 6 plus 14 over 6. Now I'm technically going to multiply every single thing by 6 to cancel out the denominator. And now I can just solve the equation negative 9x plus 15 equals 4x plus 14, and I can start swapping sides. So negative 9x minus 4x equals 14 minus 15. That's negative 13x equals negative 1. And when we divide both sides by negative 13, we're not going to get a nice point of intersection, but that's okay. The x coordinate is positive 1 over 13. And now we can plug this into either one of our equations. I'm going to plug it into the top one, but either one would have been fine. So that's negative 3 over 2, x is 1 over 13, and then plus 5 over 2. Now, multiply your fractions. So negative 3 times 1 is negative 3. 2 times 13 is 26. And I know I'm going to need a common denominator to add these fractions. So I'm going to turn 5 over 2 into something over 26, which means I'm going to multiply top and bottom by 13. So 5 times 13 is 65. 2 times 13 is 26. Now we can add negative 3 and 65 to get 62 over 26, and that will reduce to 31 over 13. So there's your point of intersection, 1 over 13, comma 31 over 13. So going back to our diagram, we just found this point right here. Now we can do the distance formula between our point of intersection and point C. So I'm just going to write point C over here. Point C was negative 2, comma 1. And I'm just going to highlight that so that we know where to look to for our distance. So for the distance here, you are using fractions, but when you put them into your calculator, you can turn the fractions into decimals to make it a little easier for you. So originally, I'm just going to plug in what I see. So x2 minus x1 squared plus y2 minus y1 squared. And now I did put the fractions into my calculator, but now I'm just going to do this in one step in my calculator. So negative 2 minus 1 over 13, or 1 divided by 13. And I end up with negative 2.076923. I don't care, I'm just going to square that number right away. And if you can do this step all at once in your calculator, that would be great. But if you have to do it in steps, I'll show you what you should be writing. So I simplified that first bracket, and I'm just going to put 4 decimals, okay, because I am losing accuracy here. And then for the second bracket, I'm going to do 1 minus 31 divided by 13. And then I'm going to square that answer. And I end up with approximately 1.9172 when I'm rounding to 4 decimals. Okay, and then I will add these answers. So 4.3136 plus 1.9172. And I get the square root of 6.2308. And then I will just square root this answer. And I get approximately 2.5 units for the distance. Now, if you could have plugged, depending on your calculator here, if you can just plug this all in at once using brackets and everything properly, you can just jump straight from showing me your equation to the final answer. That is perfectly fine with me. And that way you preserve a bit more accuracy. But if you want to simplify it slowly, just make sure you are keeping at least 4 decimals for each thing so you don't lose too much accuracy. Okay, so there it is. This one was a little longer. We had one extra step where we had to find the equation of the original line first. But after that, find the equation of the altitude, do some substitution, then do your distance formula. Tedious, but repetitive, and you have all the skills. All right, let's do one more, a little bit of an application type of question. So an iceberg is situated off the coast of Newfoundland at map coordinates 40, 10. A cruise ship is at negative 20, 60 and is heading straight for 50, negative 10. So that's a line for the cruise ship direction. If the cruise ship maintains the same course, how close to the iceberg will the ship get? Assume 1 unit equals 1 meter. So we can do a little sketch for ourselves just to see what's going on. And I put this grid here so that you have freedom to draw in your X and Y axis. So I'm just going to make my Y axis here. And my X axis, I'll just say, is something like this. I'll plot my points. So 40, and I'm going to say each unit is 10. So 40, 10, I'm going to plot it here as if it's 4, 1. And this is my iceberg. My cruise ship is at negative 20, so negative 20 and then 60. So somewhere here. And then 50, negative 10 would be somewhere here. So the cruise ship is going like this. And we want to see how close it gets to the iceberg. So I want you to pause the video here. And I want you to try to apply the steps that we just did above for this scenario. So based on what I just drew, your first step is to find the equation of this line. Then after that, we want to find the altitude. So step 2 is to find the altitude. Because you drew the altitude, we know we need a point of intersection. So that's step 3, the POI. And then step 4 is to find the actual distance right here. So pause the video, try it out. Be careful not to make silly mistakes with your signs and simplify your fractions. And then come back to the video to check your work. All right, so your step 1 was to find the cruise ship line. So for your slope, you're using these 2 points right here to find the slope, and you're doing -10 minus 60 over 50 minus -20. And when you reduce that, you end up with -70 over 70, which is -1. So now we can do our y equals mx plus b, and you can plug in either point. I'm going to plug in that first point, so 60 for y, and then for x I'm going to put -20. -1 times -20 is +20. And when I bring the 20 over, we change the sign. So hopefully for your y-intercept you got 40, making your cruise equation y equals -x plus 40. Now if you made a mistake with that, check to see where you made your mistake. And then from here, maybe pause the video and fix your point of intersection later on. Okay, but our second step from there was to find the altitude. And for the altitude, we know our slope is perpendicular to that -1 that we got up here. And the negative reciprocal of -1 is +1. So we have y equals 1x plus b. And the point that you're plugging in here is the iceberg, which is 40, 10. Nothing else, because you don't know any other point on the altitude. So we have 10 equals 40 plus b. Bring that 40 over and change the sign. So hopefully you got -30 for your y-intercept, making your altitude equation y equals x minus 30. There we go. We did step 1 and 2. So find the equation of your original line, find the equation of your altitude. Step 3, if you have two equations, the only thing you can do with them is find the point of intersection. So I'm going to do a substitution here. And I'm going to write x minus 30 equals -x plus 40, or the other way around. Move some things around. So x plus x equals 40 plus 30. Don't forget to switch your signs throughout. So 2x equals 70. Divide both sides by 2, and you get 35 for x. Now that we have our x coordinate, let's sub it into either equation. I'm just going to sub it into that second one. So 35 minus 30, and we get 5. So our point of intersection is 35, 5, and our iceberg was at 40, 10. So that takes us to our last step, which is the distance, because we want to see how close the ship got to the iceberg. So let's go ahead. If up to here you've done everything correctly, that's perfect. You know how to find the equation of the line, like in grade 9, right here. You know how to find the equation of your altitude. You know how to do substitution or elimination from the previous unit. Now it's just the distance formula that we also did in the previous unit. So x2 minus x1 squared plus y2 minus y1 squared. 40 minus 35 is 5, and 5 squared is 25. 10 minus 5 is 5, and 5 squared again is 25. So the exact distance is the square root of 50, and the round distance is going to be approximately 7.1. And if we go back up to see what our therefore statement should be, you should know that 1 unit is 1 meter. So in our therefore statement, we can say, therefore, the ship gets 7.1 meters away from the iceberg, or something like that. And there it is. That's your shortest distance.